Now we will solve these three questions. So our first question says that how many types of charge carriers are there in a MOS? So if we talk about PMOS and NMOS, we have to talk separately about them. So in PMOS, although we have electrons as well as holes, both, still our charge carriers are only holes. So we will write here only one type, and that is holes. And in NMOS also, electrons and holes both are present. But we are talking about the charge carriers, and charge carriers are responsible for the flow of current. So here in NMOS, electrons are responsible for the flow of current. So here also we will write only one type, and they are electrons. So this is the solution for the first question, that in PMOS only one type of charge carrier is there and they are holes, and in NMOS also only one type of charge carriers is there and they are electrons. Now we will see the second question. So second question says that what is the need of oxide layer in MOS? So first we will see what happens in NMOS. In NMOS, this is source, this is drain, this is substrate, oxide layer, metal layer, and then this is the gate terminal. Here we have drain terminal, here we have source terminal. So here we are talking about enhancement, but if we talk about the depletion type MOSFET also, then also the reason will be same. So first of all, we will see here that in this MOSFET, for forming the channel, we need to apply positive voltage at the gate terminal. So from this negative terminal of this positive voltage, electron will come and they will go into the P substrate, and in P substrate what we have? We have negative ions paired with holes. So these electrons from the negative terminal will come and go into the P substrate, and they will recombine with these holes, and after the recombination of all the holes of the P substrate, still electrons will be going into the P substrate, and those electrons will form here the channel. So now we can show here like this, that this is the metal layer and this is gate terminal, and this is the semiconductor one, this one semiconductor. So since we are applying positive voltage at the gate, we will show here positive sign, and we are having the N channel which is formed by electrons, so we will show here the negative sign, and this is oxide layer. So if oxide layer wasn't there, then what would happen? If oxide layer wasn't there, then these electrons will go to the metal layer and they will just get neutralized, and when these electrons will get neutralized by going into the metal layer, there won't be any channel left, and without channel there won't be any conduction of current. So we can say that oxide layer, that is when we put oxide layer here, it acts as the insulator and it stops these electrons to go to the metal layer and neutralize. So we can write here that oxide layer in NMOS stops electrons to go to the metal layer and get neutralized. Thereby allowing the conduction of current. Now, let us see what happens in PMOS. If we talk about PMOS, then source, drain, and this is N substrate. This is oxide layer, metal layer, gate terminal, drain terminal, source terminal, and for the formation of channel in this PMOS, we need to apply negative voltage at the gate. And from this positive terminal, holes will come and they will go into the N substrate. And in N substrate, what we have? We have positive ion paired with electrons. So these holes will go into the N substrate and they will be combined with these electrons of the N substrate. And after the recombination of all the electrons, still these holes will be coming into the N substrate and they will form here the P channel. So now if we show here like this is metal layer, oxide layer, and this is our semiconductor. So since we are applying negative voltage at the gate, we will show here the negative sign, and since our channel is of P type, that is P channel formed by holes, so we will show here the plus sign. If oxide layer wasn't there, then what would happen? These holes will go to the metal layer and they will just get neutralized and no formation of channel will be there. Hence, no conduction of current will be there. And when we put oxide layer here, our oxide layer acts as the insulator and they stop the holes to go to the metal layer and get neutralized. So we will write that oxide layer in PMOS stops the holes to go to the metal layer and get neutralized. Thereby allowing the conduction of current. So this is for PMOS. Now we will see the third question. So our third question says that why do we use MOSFET in enhancement mode for amplification? So first let us draw one enhancement mode MOSFET and this is gate terminal, this is drain terminal, and this is our source terminal, and this is our body terminal. So this is enhancement type MOSFET because here we don't have a channel, and in enhancement type we don't have channel. So we know that for the creation of this channel we need to apply some voltage at the gate. That is, without applying VGS, channel won't be formed. So no current will flow. That is, without applying the VGS, channel won't be formed, and without channel we know that charge carriers won't be able to travel from source to drain, hence no current will be flowing, because what is current? Current is the flow of charge carriers. Now we know that VGS is the input, and in enhancement mode we can see that without applying any input we don't get any output current. So we can say that in enhancement mode output current, or you can say that output is dependent on the input. And this is the basic rule for the amplification. Like for amplifier, if we say that V naught, that is, this is output voltage, is equal to K into Vi. So we can say that here our output voltage is dependent on input voltage, because here the output is equal to input voltage multiplied with K. So we know that without applying any input voltage we won't get any output voltage. If Vi is equal to 0, Vo equals to 0, K into 0 equals to 0. So this is the basic rule for an amplifier, that our output should be dependent on the input. And in enhancement mode we can clearly see that without applying any VGS we won't get any output current. So that is why we use MOSFET in enhancement mode for amplification. So this is it for this video, and we will see some more questions in the next video. Thank you.